Welcome all to my channel NS Easy Maths. Here in this class today we are discussing CBSE 10th standard mathematics first chapter real numbers. In that chapter there is an important section LCM and HCF of two numbers and the connection between these. Okay, this is not only for CBSE students. I am discussing this class based on that textbook, but it is useful for all other syllabus also. See, HCF and the LCM is the basic thing in mathematics and many students have doubt in that section. And here in detail we are discussing the HCF, how to find the HCF by using prime factorization and how to find the LCM by using prime factorization. And we are studying an important connection between LCM and HCF, that is product of LCM and the HCF of two given positive integers is always equal to the product of that two numbers that we are discussing in this class. Okay, so we can come to the class. See, here we have two numbers, two positive integers. They are 40 and 60. And we have to find the highest common factor, the HCF of these two. In this chapter, the first chapter of CBSE 10th standard, we are studying the common factor. We are studying to find the highest common factor by factorization, prime factorization. Before going to that, at first we can discuss what do you mean by the highest common factor of two numbers. Okay, we can discuss that before finding the highest common factor by using prime factorization. For that, we have taken two numbers 40 and 60. At first we can write the factors. Look at this highest common factor we have to find. H for highest, the largest, and C for common, and F for factors. Before finding highest common factor, we can find the factors at first. What are the factors of these two numbers? So I written here the factors of 40. These are the factors of 40. What do you mean by factors? By using these numbers, you can divide the number 40 completely without any remainder other than 0. And similarly, the factors of 60 are these numbers. So we have factors. We wrote the factors. Then take the common factors. See, the common factors are, look at the common factors here. 1 is common, and 2 is common. 4 is common, yes, 4 is common. 3 is not common factors. Only for 60, that is the factor 3, but not for the number 40. And 5 is common. 8 is not common, and here it is not 16, sorry, it is not 60, it is 6, okay. Then 6 is not a common factor, 10 is common, 20 is common. So the common factors are 1, 2, then 4, 5, 10 and 20. These are the common factors. But we are finding highest common factor. Among these common factors, which is the highest? 20. So HCF of 60, 40. HCF of 60 and 40 is equal to 20. Right? This is the concept of HCF. This is the meaning of highest common factor. Write the factors of both the numbers and then select the common factors, then identify which is the highest common factor. So here 20 is the highest common factor of 40 and 60. So it's HCF is equal to 20. Okay, then without writing all the factors and then selecting the common factors, then taking the highest, we can apply prime factorization. So at first we can factorize 40 by using only prime numbers. See, 40 can be prime factorized. What are the prime numbers? 2, 3, 5, 7, 11, 13 etc. These type of numbers are called prime numbers. So you can take any number from that and you can divide this 40. So I wrote here 2. By using 2 we can divide 40, we will get the quotient as 20. Again by 2 we will get to 10. Again by 2 we will get to 5. At last we got a prime number. Then we can stop the procedure. This steps here. See, 5 is a prime number. So 40 can be written as 40 is equal to the prime factorization. 40 is equal to 2 into 2 into 2 into 5. 2 into 2 into 2 into 5, which is equal to, what is 2 into 2 into 2? 2 raised to 3 into 5 raised to 1, or 5 itself. Similarly, we can factorize 60 by using prime numbers. Take a prime number. By using that number, you can divide the number 60. So, I taken 5. 5 on dividing 60 by 5, we get to 20 as the quotient. Again, we can divide by using 3. Use only prime numbers. Then we get to 4. 4 is not a prime number. So, we can divide this 4 by using 2 again. We will get to 2. 2 is a prime number. So, 60 can be written as 5 into 3 into 2 into 2, which is equal to 5 raised to 1 into 3 raised to 1 into 2 raised to 2. Is it clear? That is prime factorization. Then, what is HCF? By using prime factorization, how can we find the HCF? In your textbook, 10th standard CBSE, there is a definition for HCF. HCF is the product of smallest power of each common factor. Product of smallest power of each prime common factor. So look at these prime factors and take the common. 2 is common for both 40 and 60. 5 is common for both 40 and 60. Then take the smallest power of these. Look at this 2 here and here, and here it is written as 2 cube and here 2 square. Then which is the smallest? These two are here. These two are common prime factors. And among that, the smallest power is 2 raised to 2. So take 2 raised to 2. Then into next common prime factor is 5 and 5. Among these two, which is the smallest power? Both are 5 raised to 1. So smallest and also the largest is 5 raised to 1. So take 5 raised to 1. Then the product of these two is 4 into 5 equal to 20. 20 is the HCF. Here already we found the HCF by using the basic concept. We return the factors, then taking the common factors and take the highest common factor. It is by using the method of prime factorization. How can we find the HCF? At first write the prime factors of 40, then the prime factors of 60 and take the common. Here 2 and 5 are common prime factors. Among that, the smallest power in 2 is 2 raised to 2 and the smallest power in 5 is 5 raised to 1. Product of these two is the HCF. So 2 raised to 2, 4 into 5 raised to 1, 5, 20. This is highest common factor of two numbers. Similarly, the highest common factor of three numbers also can be found by using the method of prime factorization. Next, we are finding how to find the LCM, lowest common multiple. I already told you that there is a connection between LCM and HCF with the given two numbers. Before going to that connection, next we can find how to find the LCM of two numbers, the least common multiple. Okay, look at the two numbers 12 and 16. We are going to find the LCM of 12 and 16. We have to find the lowest common multiple. So at first we have to write what? The multiples. What are the multiples of 12 and 16? Look at this. Multiples of 12, 24, 36, 48, 60, 72, 84, 96, etc. going on. And multiples of 16, 32, 48, 64, 80, 96, etc. So these are the multiples of 12 and 16. Then next, which is the common among these multiples? What are common here? Look at this. 48 here and here also 48. 96 here and here also 96. So the common multiples are 48, 96, etc. Then there are many numbers common for these two, 12 and 16. Not only these 48 and 96, etc. There will be many numbers. So these are the common multiples. Then we are taking the least common multiples. Among these common multiples, which is the least, which is the lowest, which is the smallest? No doubt it is 48. So LCM of 12, 16 is equal to 48. 48. This also can be found by using the method of prime factorization. How can we prime factorize this? See, instead of writing the prime factors separately, we can take the numbers together. Look at this. 12, 16. 12, 16. Prime factorization. Together. Take a number. By using that number, we can divide 12 and 16, both numbers. That is 2. So here we will get 6, and for 16 on dividing with 2 we will get 8. Again we can take 2, here 3 and here 4. Then we can again divide with 2, but this 3 is not divisible by 2 because 3 is a prime number. So just write that 3 here. Then by using this 4 can be divided by 2 and we will get 2. So last we got prime numbers. So 12, 16, the LCM is equal to multiply these numbers. 2 into 2 into 2 into 3 into 2. So LCM is equal to, this is 8 into 6, 48. Okay, LCM is 48. So by using prime factorization, we can factorize this 12 and 6 together and then multiply these outermost numbers 2, 2, 2, 3, 2. We will get the LCM directly. So this is the method of finding the LCM. Then what is the connection between the LCM and the HCF with the given two numbers? That is the conclusion of this part. So we can discuss that next. See, we already found the HCF of 40 and 60 at the beginning of this class, and we got 20 as the answer. HCF of 40 and 60. We can find the LCM of the same numbers 40 and 60. We can use a prime factorization. LCM, take 2 and here 20 and here 30. Again divide with 2. We will get 10 here and 15 here. Then you can divide with 5 because 10 and 15 both can be divided by using 5. Here 2 and here 3. These 3 and 2 are prime numbers. So we can stop the work here, and LCM is equal to 2 into 2 into 5 into 2 into 3. 2 into 2 into 5 into 2 into 3. What is the answer? 4 into 5, 20. 20 into 2, 40. 40 into 3, 120. 120 is the LCM of 40 and 60. 120. So we got the HCF and the LCM. Just to multiply HCF and LCM. LCM into HCF is equal to 120 into 20, which is equal to 2400. Okay, this is the product of LCM and HCF of these two numbers. Then we can multiply the numbers. Now, product of 40 and 60 is equal to, what is 40 into 60? 2400. This and this both are equal. So it is the connection, it is the relationship between LCM, HCF and the given two numbers. Product of LCM and HCF of the given two numbers is equal to the product of the numbers. So LCM of A comma B into HCF of A comma B is equal to A into B, right? LCM of A comma B into HCF of A comma B is equal to A into B. By using this connection, we can find the LCM if the HCF is given, and also if the LCM is given, by using that we can find the HCF. Okay, see, we can do only one example, only one question by using the connection between LCM and HCF with the given two numbers. Here, two numbers 306 and 657 given. It is a question in your textbook. Given HCF of these two numbers is equal to 9. The question is, find the LCM of the same numbers. Okay, no need of prime factorization here to find the LCM. We can apply the connection between these. We know that LCM into HCF is equal to the product of the given numbers. LCM of these two into HCF of these two is equal to the product of these two. That means LCM. We don't know what is LCM. So write LCM into HCF is given in our question 9 is equal to the product of these two numbers is 2,1042. Therefore, by solving this equation, we can find LCM is equal to 2,1042. Bring this 9 to right side, we will get to 9. It's become divided by 9. On dividing these two, we will get 2, 2, 3, 3, 8. That means 22,338. This is the LCM of the lowest common multiple of the given two numbers. So it is very simple to find the LCM if the HCF is given, or it is very simple to find the HCF if the LCM is given. For that, we will apply the connection. What is the connection? Once again, I'm telling you, LCM of two numbers into HCF of the same two numbers is equal to the product of that two numbers. Okay. See, one more example. How can we find the LCM of? This is also a question in your exercise, textbook exercise. How can we find the LCM of 12, 15 and 21? LCM. So we can apply prime factorization 12, 15 and 21 like this. Take a prime number. By using that prime number, we have to divide 12, 15 and 21 completely. So we can take 3. On dividing 12, we get to 4 and 15, we get to 5. On 21, we will get to 7. So 4 is not a prime, 4 is not a prime, 5 is a prime and 7 is a prime. We can stop here. Otherwise, we can proceed until we get a prime number instead of 4. So 2. On dividing 4 by 2, we will get to 2. 5 cannot be divided, so write the 5 itself. 7 also cannot be divided by 2, so write 7 itself. So LCM is equal to 3 into 2 into 2 into 5 into 7. Okay. On multiplying 3 into 2, 6, 6 into 2, 12 into 5 into 7, 35. So LCM is equal to 12 into 35, that is 350 plus 70 is equal to 420. It is the LCM. Okay, then we can find the HCF. Okay, the HCF is, to find the HCF, already we got the LCM 420, don't forget that. To find the HCF, we have to factorize the numbers separately. This is not to find the LCM, so factorize them separately by using prime numbers. So 12 can be prime factorized as this, like this, and 15, 21. So 12 is equal to 2 into 2 into 3, 2 square into 3 raised to 1. 15 is equal to 3 into 5 only, so 3 raised to 1 into 5 raised to 1, and 21 is 3 into 7, 3 raised to 1 into 7 raised to 1. And what is HCF? Take the common, the largest, so the smallest power of each common prime factors. So what are the common prime factors here? Common for these three, only 3 is common for all the three numbers. Okay, so 3 is common, and which is the smallest power? 3 raised to 1. So HCF is equal to 3 raised to 1 is equal to 3. Okay, now I am winding the session. Same, in this section we have discussed the LCM and the HCF of the given numbers, and we studied a connection LCM into HCF of two numbers. LCM of two numbers into HCF of that two numbers is equal to the product of that two numbers. Okay, and how can we find the LCM and the HCF? Okay, see, for more classes for CBSE students, please subscribe this channel NSEC Maths and just press the bell icon, and we will meet again. Goodbye.